Hi class, let's study for Unit 5 test in the class Computer Science Games and Apps, which is a test based on the programming language Python at the school where I teach. We have a true-false section. If anybody can read this and raise their hand and accurately answer, I'd appreciate it, but otherwise I will read it. Oh, Scott, true or false, is the step amount 3 here in this range function? True, definitely true. The third number is considered the step amount if there is a third number. And there is a third number there, that 3 is the step amount. The 1 is the beginning value for the variable I that you would typically have. The 5 is the endpoint. Actually, it's 1 greater than the endpoint. And 3, which is optional, they have it typed out there, it's the step amount. In the lecture notes that you can consult, I sometimes call it the step size, but it's you can also think of it as the step amount. That is definitely true, and let's just record that as a true. True. Number 2, is this an example of a counter statement? And on top of that, are counter statements often indented, as Python requires, in the body of for loops? Heck yes. True. And by the way, this counter statement is counting by ones. Now, if I had a 2 there, it'd be a counter statement that just happens to count by 2s. Number 3, would this loop using the formula high minus low that we studied in our notes and when we practiced, is the formula high minus low, does it simplify to 5? What do you say to that, Scott? False, correct. And even though you might not have to do this on my test, how would you make that 5? Or what would you put there to make it a true statement? Anyone? 4, because high minus low here would be the h minus the low of 1. And that's how many times a loop would go around. So if there was something indented inside the body of that for loop, like print hello, the word hello would appear 4 times because that loop goes around 4 times there. Number 4. Oh, one of those situations where we have 3 parameters, kind of like exercise 1 was. Now we know that 2 is the step amount, and we know that 4 is where the variable I starts, and we know it goes up to but not including the 10. So just count on your fingers and toes. You don't have to make up a problem that prints like hello world. You could probably do this in your head or with tally marks in your sketchbook, or if you know the fancy formula that may or may not be in my notes depending on what year you're watching this video. There is a formula, I want to get into it because it's kind of advanced, but I'm just going to figure it out in my fingers and toes. I starts at 4, it goes through the loop, it goes up by 2 to 6, it goes through the loop, tally mark, it goes up to 8, and it goes through the loop, tally mark, and it would go to 10, but it's not allowed to in Python, it doesn't hit the 10, so it just knows to stop after those 3, count them, 1, 2, 3, 3 loop iterations. No way is it 10, 6. Oh, if you did high minus low here, you get the common wrong answer of 6. But because of that 2, it's really 6 divided by the 2, and it's 3. So anyway, either way, it's false. Number 5. Now, when you have just one number in the parentheses, it's the same thing as having a 0 first, then the number that you have there, 4, and then a comma 1, because it's always a comma 1 by default as a step size. And so basically here, high minus low would be 4 minus that low of 0. Correct, 4 times. High minus low, that 1 just means you go by ones. So that's definitely true. Number 6, yes. This is an equivalent way of typing out that. I myself prefer this because it's shorter. It's just easier. Plus, this really fools algebra teachers. When algebra teachers see this, they mark it wrong. Because if you subtract sum from both sides, if you subtract sum from both sides here, you end up with 0 equals 0 plus 1. which further simplifies to 0 equals 1, which is a contradiction in the world of math. It's considered wrong in pretty much every textbook and math class you've ever saw. So that would make no sense in math class. But in computer science, you'll see it all the time. Some computer languages don't support the plus equals operator, and they force you to do it this way. Now, Python allows you to do it either way. And I personally prefer this, although I would not take off points if a student typed it out like that. But they are equivalent, so this is true. By the way, if you want to read the text version of all that talking that I just did, go read my lecture notes or a book about Python. It's probably like page 258. So good luck reading the first 200 pages to get to that. So I would just read my lecture notes or watch this video a second time. Number 7. Yes, by definition, no, I didn't read the whole problem. When a for loop has a variable like I, it is called a control variable, and sometimes we call it the loop variable. But never make it Z. It makes no sense to make it Z, even though it technically would work. It's common to use I. It's a very famous name for a loop variable in a for loop. So that's definitely false. Don't go around and use Z, and don't use any other letter of the alphabet. Don't use Z, Y, X, W, V, U, T, S, R, Q, P, O, N, M, L, K, J, S, G, F, E, D, C, B, A, except for the I in there that I said by accident. 8. Yes, read the notes or pretty much any textbook on introductory computer science. For loops in any computer language are called definite loops. Sometimes we call them determinate loops, basically the same thing. And then while loops, which we don't know when they stop because it's usually up to some random number, or worse, the mind of the customer, which we can't read people's minds, so we don't know when they're going to stop buying things and take their shopping cart and check out a Walmart. We don't know when they're going to stop. And they might even get a second cart or a third cart. So we don't even know when the first cart is at capacity. They could shop all night long at Amazon.com. So a while loop is typically used in those situations where user interaction is involved, maybe a game. But a for loop is when you know that everybody in the amusement park always gets to go around the merry-go-round 10 times. The computer controls it, not that person working the ride. They're just sitting there making sure little kids don't fall off the merry-go-round, or so that kids wear seatbelts. They're checking the seatbelt mechanisms. But the machine, I think these days, it's a machine that counts. And you're done after 4i in range 10. So this is true, and this is true also. Let's move on and look at the rest of this practice test. Typically, you have to trace code, whether it's an AP exam that you might take at a high school level, or it's in the real world where your boss or your coworker did something that's wrong, and you have to trace his or her code to figure out where it was wrong. Now, some people, they can just do this stuff in their head. I can see that the high minus low here is 7. So I know that I will end up being, 7, yep. Well, because it goes up to but not including the 8. I know the pattern is this, ... And I know that if you iterate 7 times and you're giving somebody a $2 bill each time they go around the merry-go-round, so you essentially gave them 7 $2 bills, I know that the final answer of 2 times or star 7 equals 14. I know this is going to be a 14. Some people, when they see print sum, they put 7 there, which is totally wrong because the 7 is the final number in I, and I don't have an I there, it's 7. So that's wrong. And some people use pen, and I hate that because it just makes their test sloppy. So they should be using an eraser and cleanly put the correct answer there, which of course we all know by now is sum, which is currently the stored value 14. So some people can do a problem without tracing it. But sometimes teachers and professors want to see the work. It all depends on the teacher's directions, and it does say trace, showing the variable's values. So unfortunately, that is either partial credit or no credit, putting the ... there that I had. So let's trace it real fast. And you can always like fast forward this YouTube if I'm boring you because you've already studied this inside and out. But here goes anyway. Sum starts at 0, check. I starts at this lower endpoint 1, check. We do go through the loop once, sum plus equals 2, that goes up to 2. We go back up to the top. The default step amount is a 1. Whether you saw that or not, it goes up by 1s. It does go through the loop again, a second time in fact, and 2 more gets added there. It goes back up to the top. 1 more gets added here. It goes through the loop again, 6 for sum. Goes back up to 4. Goes through the loop again, 8. Now don't be confused. You are allowed to have sum go to 8 because it's I. That's the control variable that determines when you stop. So we keep going. I is 5. That's still legal. It's legit. So we add 2 more to this. Ooh, another $2 bill. Cool. More. Go back up. I goes to 6. Don't fast forward here. Just follow along. 2. Go back up to the top. And now this is where the car stops. If you pull, no, it doesn't. It goes up to 7. See, I thought it was going up by 2s, but really it's going up by 1s. I was looking at the wrong number. Yep, it just went up to that 7. So we go through the loop yet again for 2 more dollars. When the teacher doesn't give you enough room, maybe you want to start a new column there, whatever. 14. I go back up to the top. And this is where Python's a little tricky. We knew that the fun time had to stop at some point. Otherwise, it'd be called an infinite loop, which is no good. Because we'd be doing this forever. We'd never even be able to sleep. And by the way, I should erase that because that's sloppy. So at this point, if we were to go 1 more step amount, we would hit that 8, and that's not allowed in Python. So we just know to stop there, circle this I, and know that that was the last value for I, and we just know not to go through the body of the loop again. Instead, we drop down to any remaining code that's indented evenly with the F, and right there it is, print sum. Sum is the 14 that I circled there for good style. See, circling, final values. And the 14 is what prints. The 7, I don't care to see it there, but I will take off the point if you don't have the 7 circled there. Okay, I'll go a little bit faster on number 2, not to confuse people, but just, well, because you can always see me for extra help if you actually have me as a face-to-face teacher. But if you're one of the thousands of people that typically watch my videos elsewhere, well, then maybe you can email me or ask a comment. I may or may not be able to get back to you. But maybe I have students that can get back to you. Sum equals 0. That was already supplied. The I starts at 2 this time. Sum goes up by 1, $1 bills each time around the merry-go-round. I goes up by 2s. Interesting. It's kind of like the opposite of the previous problem. We're not even close to 12 yet. So we go through again, and we add 1 more. We go back up to the top of the loop. We add 2 here. Be careful what you're adding. 6. We go up by 1 more. We go up to 8. We go up 1 more. Can we go to 10 here with I? Sure, you're not at 12 yet. That's the endpoint. We go up 1 more for sum. Can we go to the 12? What do you say, Scott? Can I put a 12 here? Look. No, we're not allowed to in Python, so we circle that. We stop, so we circle that. Now, every once in a while, like an AP exam, they'll after having you print sum for 5 exercises in a row, they'll have you print I, just to see if you're paying attention. You got to think like a computer. You can't read the context and know that the teacher just kind of messed up because the teacher's human. No, you have to act like a computer. You must print what the computer tells you to print. And sometimes the teacher does that on purpose, just to see if you can stay focused. So printing sum means in this problem, printing a 5. Number 4, it's an indefinite while loop. So we can't just count it out like this. We have to be told what the outside force, like the force in Star Wars, the outside force is in the mood to enter 4, 3, 1, -5. And that's just the way it is, so read directions. So sum and num both start at 0. Check, check. Oh, the way a while loop works, we've already studied this, it's either true or false. So right now, is 0 greater than or equal to 0? Yes, it is. That would be a true. So because that's true, we do iterate through the loop at least once. And now num, because of the way input works and because of the way the int function works, whatever number they input as a string, it's going to have its double quotes erased behind the scenes in such a way that the number 4 is, I'll just make up a word, integerized. It was a piece of text, like my zip code 19610, and it was integerized, meaning it's now the number 19,610 without the double quotes. I made up that word, don't go around saying it, people will look at you strange, but to integerize something means to change it from text to a number. Anyway, it's something that computers need because they are dumb. Humans can figure out whether it's a zip code or not. Now, if you lived in California, where your zip code is like 90210, some stupid TV show from the 90s, 80s, my opinion only, 90210. See, they might not know that 19610 is a famous zip code where I live. Of course, I didn't know that that was a famous zip code until they made a TV show about it. So a computer doesn't know. You must tell it when to turn something into an int or not. So anyway, we got a 4, and the 4 is now there, crossing out that 0, and the 4 is being added to the current 0 that's there, which that, by the way, simplifies to 0 plus 4 is 4, and that 4 plugs in from right to left to sum. So we got to cross that out and make it a 4. And now we kind of erase that because I'm getting sloppy. And we look up at the top of the control expression. Is this currently true? Yes, 4 is indeed greater than or equal to 0. That's a true. So we go through the merry-go-round the second time. But we need the user to input something. So luckily the teacher told you to assume it's a 3. So that 3 kind of plugs in there. And that 3 gets added to whatever's currently in sum, which is currently 4. You got to stay on track here. So now that subtotals to 7. The 7 goes in there. You know what we're doing? We're just adding that 4 plus 3 to get 7. But the computer can't just like take its human eyeballs and scan from left to right, adding, because the computer did not grow up doing rocket math. First of all, the computer doesn't have human eyeballs. And some people are blind and they read this in Braille, but the computer doesn't have fingers either. In fact, the computer has no senses. Take a higher level class to hear what the computer does have. I don't know what it does have, actually, so I better prep for that class because I'm not sure what a computer has that humans don't. It pretty much has code that we type into it, and it only does what we tell it to do. It has wires, but we made those wires. Okay, stop whispering things at me because I'm not sure. I'll get back to you in another video. Okay, I'm going to fast forward here because I think you got the deal, and I don't want to give you all the answers in this video, but something happens with that 1 and that -5. At some point, this becomes false, which means we don't do this anymore. And at that point, we circle some number that's here and some number that's here. And then we print sum. So whatever that number is right there, that question mark, the one that's a double question mark, not the single, that one's the one that prints out. Figure that out on your own time. I'm going to scroll down a little bit in this practice test. Oh my gosh, we have to write code. Now, if you have a test and they have this page that you're allowed to look at, unlike the Pennsylvania PSSA test, where I think they say you can't look at previous pages. Sometimes, maybe not anymore. Well, at this point, you could look at this for loop here and kind of use it as a starting point for this. So if you're allowed to do that, you're allowed to do it. But if you're really good, you probably don't have to. So I'll pretend that I'm really good and I write the word for, and the word print somehow gets used. I'm not sure how yet. But we have to write a for loop that iterates 5 times. I do remember from studying that it works for I in range. And range either needs 1 number, 2 numbers, or 3 numbers in its parentheses. Well, let's keep it simple, stupid. Simple, and just put 5 there. And now what is it that we want to do? What's that job for the function? to display your first name. And by the way, in Python, you must indent. I don't have a first name. I'm a teacher. Teachers are people that are born without first names. So I'll just call my first name MR, Mr. There, that's the answer. And we move on to number 2. Okay, that was a delay waiting for somebody to correct me, but everybody's afraid that's in the room right now. Emily, we need double quotes. MR is not something you can type into a calculator. It's not a number. It's not like 13. It's a piece of text. It needs to have close or double quotes around it. It just can't be naked. You just don't do that. You got to put quotes around things that are text. So that would be the right way to format the answer, where the MR is like your first name. And now we did task number 1. Number 2, another for loop. And I even tell you to use the control variable I. Don't be a rebel and use Z up here. That's just wrong, even though it wasn't like used or specified rather. Here it's being specified. Now I'm not specifying, I am specifying use the range function. I didn't up here. There were other ways to do this. I don't want to get off the track, but I will a little bit. For I in 1, 2, 3, 4, 5, what's called a list, in square brackets, still having a colon here, we could basically do that and still get the job done. But we're not using the range function, which was taught in this chapter, even though technically this would work. In fact, if you put any 5 things separated by commas there in a way, it would work, but I don't want to do it that way. That's kind of bad style. Exercise number 2, however, it's very specified. And if you ever take an AP exam or work for a boss that's really strict, and they tell you to use the range function in the letter I, then do it. So here it is for I in range. From 1 to 5. Okay. Oh, that's easy. So this prints the numbers 1 through 5 because it does iterate 5 times. Moving on, and I did indent there as I should. I'm pausing. Emily, speak up, please, because save me. My video's tape is rolling.
What is it? Integers from 1 to?
Oh, we're supposed to print the integers 1 to 5. So the output should be like 1, 2, 3, 4, 5 on a console output window that at the website Replit, for example, they give you this like way to print. Wait, so this is currently printing 0 through 4 done this way. And I need 1 through 5. So this would be technically wrong, but I could fix it by doing this. That's the number 1, and that's the letter lowercase I. Elise, in your quick view, would that work to get the right answer? Steve Grace. I think it would. To be figured out later, but I'm just going to now clean it up the way it should be for argument's sake, if not easy to grade for the teacher that grades this. Let's just keep it simple and print just the value stored in the variable I like I originally thought it would work. But right here, instead of just putting a 5, put 1, 6. Now it clearly will print the values 1 through 5 because that's what I does in that loop. So that's the way I'll leave this answer key. And number 3, I may or may not have time here in this long video to address number 3. Number 3, I'll give you some hints, but not the whole answer. It's a for loop that by rules uses I, by rules uses the range function, and by the hint that's recommended, you'll want the step size to be specified here after this comma. And whatever you're doing here, you're printing I just like we did in the previous problem. So the only thing left for you to do is to fill in the three numbers that go there and there and there based on this 3, this 9, and the fact that you want odd numbers on the number line to be printed out. And last of all, number 4, you could like leverage a previous exercise on this test to figure this out. I heard from somebody in another class period today that there might be a logic error here. There might be a logic error. For example, if you start num at 0 and you put something here and something here, you might be off by 1. In other words, it might add this -1 into the running total where clearly we want all the integers to be added up to a grand total, but we don't want this -1 to be added up, I think. But maybe we do. I don't know. It's something called a sentinel value that either logically should be added into the total or not. But maybe if we start num at -1, it kind of makes up for the fact that we eventually, no, if we start num at 1, I should say, it makes up for the fact that we're over adding something by not reversing these 2 lines of code in the other way around. Anyway, this is a very juicy problem that has multiple answers probably. And if you're a deep thinker, like a person that gets an A in this class, you'll understand the nuances of what I just went over. Otherwise, whatever you do, write in answers and trace it to see if it logically makes sense, consistent with the directions that were given to you. But sometimes those directions are ambiguous and unclear. So my phone's ringing, so I have to go. See me if you have any other questions.